Hi everyone, welcome to today's tutorial, where we'll dive into the world of perfect numbers and show you how to write a MATLAB code to find the first 8 perfect numbers. In our previous tutorial, we learned about mersenne primes. Mersenne primes and perfect numbers are two deeply interconnected types of natural numbers in number theory. So what is a perfect number? A perfect number is a positive integer that is equal to the sum of its proper divisors, all divisors excluding the number itself. For example, the proper divisors of 6 are 1, 2, and 3. The sum of these divisors is 1 plus 2 plus 3, which equals 6, making it a perfect number. As I mentioned before, mersenne primes are closely connected to perfect numbers. In the 4th century BC, Euclid proved that if 2 raised to the power of p minus 1 is prime, then 2 raised to the power of p minus 1 times 2 raised to the power of p minus 1 is a perfect number. In the 18th century, Leonhard Euler proved that, conversely, all even perfect numbers have this form: 2 raised to the power of p minus 1 times 2 raised to the power of p minus 1. This leads us to the Euclid-Euler theorem, which states that an even number is perfect if and only if it has the form 2 raised to the power of p minus 1 times 2 raised to the power of p minus 1, where 2 raised to the power of p minus 1 is a mersenne prime for any prime p. Our previous lessons on mersenne primes will be important for understanding this one. Let's start by initializing a variable count to 1. This will keep track of how many perfect numbers we find. We'll also set n to 1, which will be incremented by 1 in each iteration of the while loop. The fprintf function will format and display data on the screen. Next, we'll use a while loop that continues until we find 8 perfect numbers. Inside the loop, we'll use MATLAB's built-in isPrime function to check if n is a prime number. If it is, we calculate the corresponding mersenne number and store it in the variable mn. We then use an if condition to check whether the mersenne number is also prime. If it is, we calculate the perfect number using the Euclid-Euler formula and print the result. Each time a perfect number is found, the count is incremented by 1. Before the next iteration of the while loop, n is incremented by 1. The loop will continue incrementing n, checking for primes and mersenne primes, and calculating perfect numbers until we find the first 8 results. Now let's run the code. Thanks for watching. If you enjoyed this tutorial, don't forget to like, share, and subscribe for more coding and math content. See you in the next video. This is Tough Nut, signing off. Happy coding.